How to read a thermometer. The mercury in a thermometer expands as it warms. As the temperature rises, the mercury rises. Here you can see the mercury at -40 degrees, at -20 degrees, at 0 degrees, at +20 degrees, and at +40 degrees. Take a close look. What's the temperature of the mercury's new location? The temperature reads +60 degrees, or 60 degrees above zero. Take another look. What's the temperature at the mercury's new location? The temperature reads -60 degrees, or 60 degrees below zero. Compare -5 degrees and -12 degrees. Here the mercury's location sits at -12 degrees, or 12 degrees below zero. As the temperature rises just a bit, the new location is -5 degrees, or 5 degrees below zero. 12 degrees below zero is colder than 5 degrees below zero. -12 degrees is colder than -5 degrees. Elevation, above sea level and below sea level. In this lesson, I'm using a fish and a bird. The fish's elevation is 12 meters below sea level, and the bird's elevation is 28 meters above sea level. The elevation of the fish is -12 meters, and the elevation of the bird is 28 meters. The surface of the ocean or the sea is sea level, or 0 meters. The distance between the sea level and the fish is 12 meters. The absolute value of -12 is 12. In other words, an elevation of -12 is still 12 meters below sea level. The elevation of the bird is 28 meters. The distance between sea level and the bird is 28 meters. So what's the distance between the fish and the bird? To find the distance between the fish and the bird, we would add the absolute values of their elevations, 28 and 12. 28 plus 12 equals 40. The total distance between the fish's elevation and the bird's elevation is 40 meters. This is a lesson in comparing values using greater than, less than, and equal to signs. 3 compared to -3. On the number line, +3 is to the right of -3, and that makes +3 greater than -3. Reading from left to right, 3 is greater than -3. From right to left, it would read -3 is less than 3. 12 compared to 24. On a number line, 24 would be to the right of 12, making 24 greater than 12. Reading left to right would be 12 is less than 24. Right to left it would read 24 is greater than 12. -12 compared to -24. -12 is further to the right on the number line than -24. Making -12 greater than -24. -12 is greater than -24. 5 compared to the opposite of -5. 5 is equal to the opposite of -5, since the opposite of -5 is the same as +5. 7 2/10 compared to 7. 7 2/10 is further to the right on the number line than 7, making 7 2/10 greater than 7. 7 2/10 is greater than 7. -7 2/10 compared to -7. -7 2/10 is further to the left on the number line than -7, making 7 2/10 smaller or less than -7. -7 2/10 is less than -7. -1 5/10 compared to -3/2. -1 5/10 is equal to -3/2 because -3/2 or -3 divided by 2 equals -1 5/10 or -1.5. -4/5 compared to -5/4. -4/5 is to the right of -1 on the number line, and -5/4 is to the left of -1 on the number line. Therefore, -4/5 is greater than -5/4. -3/5 compared to -6/10. These are equivalent fractions. So -3/5 is equal to -6/10. -2/3 compared to 1/3. -2/3 is less than 0, and 1/3 is greater than 0. -2/3 is less than 1/3. What is a markup in price? A markup in price is a percentage added to the original price. If a ticket to the game costs $30, a 100% markup is an additional $30 added to the price. With a 100% markup, the new ticket price would be $60. With a 200% markup, you add $60 or 200% of the original price. If you add a 200% markup to a $30 ticket, you'd have to add $60 to the $30, and the ticket after a 200% markup would cost $90. Yellow and blue make green. In this case, mixing 2 cups of yellow paint and 3½ cups of blue paint make this shade of green. Find a mixture that will make the same shade of green, but a smaller amount. We could mix half the amount of yellow paint and half the amount of blue paint. That would give us the same shade of green, but a smaller amount. Half of 2 cups of yellow would be 1 cup of yellow. Half of these 2 cups of blue would be 1 cup of blue. Half of this 1 cup of blue would be half a cup of blue. And half of this half a cup of blue would be a 1/4 cup. So the new mixture would be 1 cup of yellow paint and 1 75/100 of a cup of blue paint, or 1 3/4 cups of blue paint. Find a mixture that will make the same shade of green but a larger amount. One easy way would be multiply each color by 10. 2 cups of yellow paint become 20 cups of yellow paint, and 3 5/10 cups of blue paint becomes 35 cups of blue paint. So this larger mixture would be 20 cups of yellow paint and 35 cups of blue paint. To keep the same shade of green but have a larger amount, we kept the same ratio, we just added 10 times more of each color. Find a mixture that will make a bluer shade of green. So now we're not going to have the same ratio. To make a bluer shade of green, we need to increase the ratio of blue to yellow. The number of cups of yellow paint will remain the same, but we'll increase the number of blue cups of paint. To make a bluer shade of green, we'll use 2 cups of yellow paint and 5 cups of blue paint. Find a mixture that will make a more yellowish color green. To make a more yellowish green color, we'd have to increase the ratio of yellow to blue. To increase the ratio of yellow paint to blue paint, we can either increase the amount of yellow paint, or we can decrease the amount of blue paint, or we can do a combination of the two. In this example, I used 3 cups of yellow paint and 3 cups of blue paint to make a more yellowish color green. A lesson in elevation. Here's a simple illustration with the ocean, mountains, and a valley. The black dotted line represents sea level. Above the line would be above sea level. Below the line would be below sea level. Sea level is an altitude of 0 feet. Above sea level is a positive value, and below sea level is a negative value. This mountaintop represents an elevation which would be above sea level, and the valley floor represents an elevation that would be below sea level. This distance represents approximately 200 feet. The elevation of this point on the hill is approximately 200 feet above sea level. The elevation of this point on the valley floor is approximately 200 feet below sea level. 200 feet above sea level would be represented with a positive 200 feet, and 200 feet below sea level would be represented with a negative 200 feet. 0 feet represents sea level. The further you go below sea level, the larger the negative number. The further you go above sea level, the larger the positive number. The peak of this mountain or hill is 500 feet above sea level. That means the elevation is 500 feet. And the valley floor is 200 feet below sea level. That means that its elevation is negative 200 feet.
Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 2, Changing Temperatures. Problem number 1. A. The temperature is negative 2 degrees Celsius. If the temperature rises by 15 degrees Celsius, what is the new temperature? Since rises means increasing, we can look at this as negative 2 plus positive 15. That, of course, is the same as negative 2 plus 15. And you can rearrange the order and rewrite this as 15 minus 2, or 13. The new temperature would be 13 degrees Celsius. B. At midnight, the temperature is negative 6 degrees Celsius. At midday, the temperature is 9 degrees Celsius. By how much did the temperature rise? The information tells us that at midnight, the temperature was negative 6 degrees, and then at midday, the temperature was positive 9 degrees. The number of units between negative 6 and positive 9 is 15, so we know that the temperature increased 15 degrees. We can also look at it as 9 minus a negative 6. Negative also means the opposite of, so I'd like to look at this as 9 and the opposite of negative 6. Since the opposite of a negative is a positive, we can look at this as 9 plus 6. And 9 plus 6 is 15. So the temperature changed 15 degrees Celsius. Problem number 2 from 7th grade Unit 5, Lesson 1. Complete each statement with a number that makes the statement true. A. We can put any number that is less than 7 degrees Celsius. 5 is less than 7, so we can put 5 degrees Celsius is less than 7 degrees Celsius. B. We can put any number that's less than negative 3 degrees Celsius. Negative 4 is to the left of negative 3 on the number line, so we know that negative 4 is less than negative 3. So we can put negative 4 degrees Celsius is less than negative 3 degrees Celsius. C. We need to find a temperature that's greater than negative 0.8 degrees Celsius and less than negative 0.1 degrees Celsius. That means that we need to find a number that's going to be to the right of negative 0.8 and to the left of negative 0.1 on the number line. I can put negative 0.5 because I know that negative 0.5 is to the left of negative 0.1 and to the right of negative 0.8 on a number line. D. This number is greater than negative 2 degrees Celsius. We need to find a number that's going to be to the right of negative 2 on a number line. -1 is to the right of -2 on a number line, so we can go with -1 degrees Celsius is greater than -2 degrees Celsius. Problem number 3. Draw a diagram to represent each of these situations. Then write an addition expression that represents the final temperature. A. The temperature was 80 degrees Fahrenheit and then fell 20 degrees Fahrenheit. That's 80 minus 20. However, they're asking us to write an addition expression. So we have to write 80 plus -20 or 80 plus minus 20. I like to look at it like this. You have 80 and you take away 20. B. The temperature was -13 degrees Fahrenheit and then rose 9 degrees Fahrenheit. Rose 9 degrees Fahrenheit, that means it increased 9 degrees Fahrenheit, so we can use a plus 9 in this expression. -13 plus 9. C. The temperature was -5 degrees Fahrenheit and then fell 8 degrees Fahrenheit. The term fell means it went lower or it dropped. That means minus. We started with a -5 and then we took away another 8. Since we need to write an addition expression, we can write -5 plus -8. Problem number 4 from 7th grade, Unit 2, Lesson 7. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would be the constant of proportionality? A. The number of wheels on a group of buses. 5 times 6 equals 30. 8 times 6 equals 48. 10 times 6 equals 60. 15 times 6 equals 90. This is proportional, and the constant of proportionality is 6. Since the number of wheels per bus is consistently 6, you can always multiply the 6 times the number of buses to find out the number of wheels in each group of buses. B. The number of wheels on a train. 20 times 9.2 equals 184. 30 times 8.8 equals 264. 40 times 8.6 equals 344. And 50 times 8.48 equals 424. In this table, the number of wheels on a train is not proportional to the number of wheels on a train car, because you are not consistently multiplying the number of train cars by the same number to figure out the number of wheels on the train. Problem number 5 from 7th grade, Unit 4, Lesson 7. Noah was assigned to make 64 cookies for the bake sale. He made 125% of that number. 90% of the cookies he made were sold. How many of Noah's cookies were left after the bake sale? He was assigned to make 64 cookies, but he made 125% of 64. So we can write 64 times 125%. Written as a decimal, that's 64 times 1.25. And 64 times 1.25 is 80. So 80 is 125% of 64. 90% of those cookies sold. So we can write this as 80 times 90%. And as a decimal, this is written as 80 times 0.9 or 80 times 0.90. And that equals 72. That means they sold 72 cookies out of the 80 cookies that he baked. 80 minus 72 equals 8. That's the number of cookies that were left over after the bake sale. 7th grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 3, Changing Elevation. Problem number 1, from 7th grade, Unit 2, Lesson 7. Decide whether each table could represent a proportional relationship. If the relationship could be proportional, what would be the constant of proportionality? A. Annie's Attic is giving away $5 off coupons. The original price, $15, is 1.5 times larger than the sale price, $10. The original price, $25, is 1.25 times larger than the sale price, $20. And the original price, $35, is 1.16 repeating times larger than the sale price, $30. Table A does not represent a proportional relationship because the original price is not consistently the same number of times larger than the sale price. Table B. Betty's Boutique is having a 20% off sale. The original price, $15, is 0.8 times larger than the sale price, $12. And the original price, $25, is 0.8 times larger than the sale price, $20. And finally, the original price, $35, is 0.8 times larger than the sale price, $28. Yes, Table B is proportional because the original price is constantly the same times larger than the sale price. For Table B, the constant of proportionality is 8/10 sale dollars per original dollar. Problem number 2. What is the final elevation if A. A bird starts at 20 meters and changes 16 meters? We can write this as the equation 20 meters plus 16 meters equals a total of 36 meters. So the elevation of the bird would be 36 meters. B. A butterfly starts at 20 meters and changes negative 16 meters. We can write this as 20 meters plus negative 16 meters equals 4 meters. We can also write it as 20 meters minus 16 meters equals 4 meters. The butterfly's elevation would be 4 meters. C. A diver starts at 5 meters and changes negative 16 meters. We can write this as 5 meters plus negative 16 meters equals negative 11 meters. We can also write this as 5 meters minus 16 meters equals negative 11 meters. The elevation of the diver would be negative 11 meters. D. A whale starts at negative 9 meters and changes 11 meters. We can write this as negative 9 meters plus 11 meters equals 2 meters. To make the math easier, you can rewrite it as 11 meters minus 9 meters equals 2 meters. E. A fish starts at negative 9 meters and changes negative 11 meters. We can write this as negative 9 meters plus negative 11 meters equals negative 20 meters. We can also write this as negative 9 meters minus 11 meters equals negative 20 meters. Problem number 3. One of the particles in an atom is called an electron. It has a charge of negative 1. Another particle in an atom is a proton. It has a charge of positive 1. The charge of an atom is the sum of the charges of the electrons and the protons. A carbon atom has an overall charge of 0 because it has 6 electrons and 6 protons, and negative 6 plus 6 equals 0. Find the overall charge for the rest of the elements on the list. Neon, negative 10 plus 10 equals 0. The overall charge is 0. Oxide, negative 10 plus 8 equals negative 2. The overall charge for oxide is negative 2. Copper, negative 27 plus 29 equals positive 2. The overall charge for copper is positive 2. Tin, negative 50 plus 50 is 0. The overall charge for tin is 0. Problem number 4 from 7th grade Unit 4, Lesson 8. Last week, the price in dollars of a gallon of gasoline was G. This week, the price of gasoline per gallon increased by 5%. Which expressions represent this week's price in dollars of a gallon of gasoline? Select all that apply. This week, the price of gasoline is G plus 5% of G. We can rewrite that as g plus 0.05 g. G can also be represented as 1g, so we can rewrite this as 1g plus 0.05 g, or 1 plus 0.05 in parentheses, all times g. 1 plus 0.05 times g is 1.05 g. All of these expressions that are written on the right-hand side represent the price of a gallon of gasoline this week. We can select the expressions B, C, and E. Problem number 5. Add A. 14 7/10 plus 28 9/10. 7 plus 9 equals 16. Carry the 1 and bring down the decimal. 1 plus 4 plus 8 is 13. Carry the 1. 1 plus 1 plus 2 is 4. 43.6, or 43 6/10. B. Negative 9 2/10 plus 4 4/10. Since the absolute value of negative 9 2/10 is greater than the absolute value of 4 4/10, we know that our answer is going to be a negative. To find our answer, we can subtract 4.4 from 9.2. And that equals negative 4 8/10. C. Negative 81 4/10 plus a negative 12. Here we're adding two negative numbers, negative 81.4 and negative 12. So we know the answer is going to be negative. 4 plus 0 is 4. Bring down the decimal. 1 plus 2 is 3. And 8 plus 1 is 9. 93.4. But these are negatives, so the answer is negative 93 4/10. D. 51 8/10 plus negative 8/10. That's the same as 51 8/10 and take away 8/10. So we're going to subtract 8/10 from 51 8/10. And 51 8/10 minus 8/10 equals 51.
Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 4, Money and Debts. Problem number 1 from 7th grade Unit 2, Lesson 8. Decide whether or not each equation represents a proportional relationship. A. Volume measured in cups, C, versus the same volume measured in ounces, Z. This equation can be written as C equals 1/8 Z. Yes, this represents a proportional relationship. Since there are 8 ounces in 1 cup, you can multiply the number of ounces times 1/8. For example, 1 ounce times 1/8 equals 1/8 of a cup. 2 ounces times 1/8 equals 2/8 of a cup, and so forth. The constant of proportionality in this case is 1/8. B. Area of a square, A, versus the side length of the square, S. This equation can be written as A equals S squared. No, this equation does not represent a proportional relationship because you're not constantly multiplying the side length times the same number to get the area. You're multiplying the side length times a different number to get the area. For example, a side length of 1 unit times 1 equals the area, 1 unit squared. A side length of 2 units, you'd multiply times 2 to get the area of 4 units squared. And a side length of 3 units, you'd multiply by 3 to get the area 9 units squared. The area does not have a proportional relationship with the side length. C. Perimeter of an equilateral triangle, P, versus the side length of the triangle, S. The equation that represents this situation is 3S equals P. Yes, this equation represents a proportional relationship. Since there are 3 sides to a triangle, you'd multiply the length of the side times 3. For example, 1 times 3 is the perimeter 3. A side length of 2 units times 3 is a perimeter 6. And the side length of 3 units times 3 is the perimeter 9. The constant of proportionality is 3. D. Length L versus width W for a rectangle whose area is 60 square units. The equation that would represent this is L equals 60 over W. No, this equation does not represent a proportional relationship because we're not constantly multiplying the width times the same number to get the length. For example, a rectangle could have a width of 1 unit and a length of 60 units. That means that the length is 60 times greater than the width. In the second example, you could have a rectangle with a width of 2 units and a length of 30 units. This means that the length is 15 times greater than the width. Since we're not constantly multiplying the width times the same number to get the length, there is no constant of proportionality, and this equation does not represent a proportional relationship. Problem number 2. A. Claire has $54 in her bank account. A store credits her account with a $10 refund. How much does she now have in the bank? Claire started out with $54 in her account, then a store gave a credit to her account for $10. That means that the store gave her account $10 or put $10 into her account. $54 plus $10 is $64. Now Claire has $64 in her bank account. B. Mai owes the bank $60. She gets $85 for her birthday and deposits it into her account. How much does she now have in the bank? She owes $60. That means minus $60. And she adds $85. If we switch the order, we can have $85 minus $60, and the difference is $25. So after she adds $85 to her account, she'll have $25 in the bank. C. Tyler is overdrawn at the bank by $180. His brother has $70 more than him. How much money does Tyler's brother have? They're both going to be in the negative. Overdrawn means that you've spent more money than you had. Tyler's bank account is at negative $180, and his brother has $70 more than he does. We can write the expression negative 180 plus 70, which equals negative 110. Tyler's brother is overdrawn $110, which is equivalent to negative $110 in his account. D. Andre has $37 in his bank account and writes a check for $87. After the check has been cashed, what will the bank balance show? First of all, if Andre only has $37 in his bank account, he should not be writing a check for $87. He should learn how to balance his checkbook and only write checks that his bank balance can cover. We can represent Andre's situation with 37 plus a negative 87, and that equals negative 50. So if he only had $37 in his bank account and he wrote a check for $87, he would have a negative $50 balance. That means that he would owe the bank $50, not to mention the overdraft charges that they would charge him to put him further in debt. Problem number 3 from 7th grade, Unit 4, Lesson 8. Last week it rained G inches. This week, the amount of rain decreased by 5%. Which expressions represent the amount of rain that fell this week? Select all that apply. G represents the amount of rain last week. This week, it decreased by 5%. That means that we need to subtract 5% of G from G, the amount of rain that we had last week. 5% can also be written as 0.05, so we can subtract 0.05 of G is the same as times G. 1G minus 0.05 G equals 0.95 G. So we can select any of the expressions A through E that represent any of the expressions that I've written on the right. B, C, and E. Problem number 4. The table shows 5 transactions and the resulting account balance in a bank account, except some numbers are missing. Fill in the missing numbers. After the first transaction, the account balance is $200. Then the second transaction, they subtract or withdraw $147. So 200 minus 147 is 53. So the account balance after the second transaction is $53. During the third transaction, they deposit or add $90. The account balance was 53. They added 90. Now the new balance is $143. During the fourth transaction, they withdrew $229. Their balance was only $143, so I'm not sure why they withdrew $229. They're definitely going to owe the bank money, and there's going to be extra overdraft fees, but not counting the fees, the new balance is negative $86. That means that they owe the bank $86. In the fifth transaction, they brought their balance to zero. So they went from a balance of negative $86 to a balance of $0. That means that they must have deposited or added $86 to their account. Problem number 5 from 7th grade, Unit 5, Lesson 3. Add A, 5 3/4 plus a negative 1/4. That's the same thing as 5 3/4 and then taking away 1/4. When you take away 1/4 from 5 3/4, you have 5 2/4. And 5 2/4 is equivalent to 5 1/2. B, negative 2/3 plus 1/6. First, let's get common denominators. 3 times 2 equals 6, so we can multiply the bottom number by 2 so that we can have a common denominator with the 1/6. And whatever we do to the bottom, we have to do to the top. 2 times 2 is 4. So negative 2/3 is equivalent to negative 4/6. Negative 4/6 plus 1/6. That equals negative 3/6. And negative 3/6 is equivalent to negative 1/2. C, negative 8/5 plus negative 3/4. Again, we need to find a common denominator. I'll use 20. Negative 8/5 is equivalent to negative 32 over 20. And negative 3/4 is equivalent to negative 15 over 20. Now the expression reads negative 32 over 20 plus a negative 15 over 20. Negative 32 plus a negative 15 is a negative 47. So the answer is negative 47 over 20. Problem number 6 from 7th grade, Unit 5, Lesson 1. In each diagram, x represents a different value. For each diagram, A, what is something that is definitely true about the value of x, and B, what is something that could be true about the value of x. Diagram A has the x marked to the left of 0 on the number line. That means that x must be a negative. What is something that could be true? Since x falls between 0 and negative 1, it looks like the x is a little bit less than halfway to the negative 1. So x could be negative 35/100ths. Looking at diagram B, the x is to the right of the 0 on the number line, so we know that the x is positive. And it looks like it's less than 1.5. The x could be 1.4. Looking at diagram C, I see that they have the x labeled as a negative x, and it's located to the left of 0 on the number line. If negative x is to the left of 0 on the number line, then positive x would be to the right of 0 on the number line. Negative x kind of means the opposite of x. If the opposite of x is to the left of 0 on a number line, then x will be to the right of 0 on the number line. So we know that x is positive. And we know that x is greater than 1. It looks like it's less than 1.5, so x could be 1.4. On diagram D, x is labeled as negative x, and it's to the right of 0 on the number line. Again, if negative x is to the right of 0 on the number line, then x is going to be to the left of 0 on the number line. So we know that x is negative. And the x looks like it's a little bit further than halfway, but not all the way to the negative 1. So x could be negative 7/10.
7th grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 7, Adding and Subtracting to Solve Problems. Problem number 1 from 7th grade, Unit 4, Lesson 10. Tyler orders a meal that costs $15. A. If the tax rate is 6.6%, how much will the sales tax be on Tyler's meal? We need to find 6.6% of 15. 6.6% can be rewritten as 0.066, and of can be rewritten as a multiplication symbol. Now the expression reads 0.066 times 15, and that equals 99 hundredths, or in this case, 99 cents. The tax on Tyler's meal will be 99 cents. B. Tyler also wants to leave a tip for the server. How much do you think he should pay in all? Explain your reasoning. Let's say Tyler decided to leave a 15% tip. Then we'd need to find 15% of 15. This can be rewritten as 0.15 times 15. And 0.15 times 15 is 2.25, or in this case, $2.25. Now to figure out how much Tyler needs to pay in all, we can start with the $15 that the meal cost, 99 cents for the tax, and finally $2.25 for the tip. Add those together, and we can expect Tyler to pay about $18.24, but he'll probably round it up to $18.25 or $18.50 or maybe even $19. Problem number 2 from 7th grade, Unit 2, Lesson 3. In a video game, a character is healed at a constant rate as long as they are standing in a certain circle. Complete the table. The left-hand column of this table is time in the circle in seconds, and the right-hand column is health gained in points. 100 points gained divided by 4 seconds in the circle equals 25. That means that the number of points gained is 25 times that of the time in the circle. 10 seconds in the circle times 25 equals 250 points gained. 3 seconds in the circle times 25 equals 75 points gained. This last row is 10 times bigger than the first row. If 4 times 25 equals 100, then 40 times 25 equals 1,000. Or 1,000 divided by 25 equals 40. Problem number 3 from 7th grade, Unit 5, Lesson 6. A. How much higher is 500 meters than 400 meters? 500 minus 400 equals 100. So 500 meters is 100 meters higher than 400 meters. B. How much higher is 500 meters than negative 400 meters? 500 minus negative 400, or 500 and the opposite of negative 400. The opposite of negative 400 is positive 400, so 500 and positive 400. That's a difference of 900 meters. So 500 meters is 900 meters higher than negative 400 meters. Take a look at this illustration. 500 meters compared to negative 400 meters. From the 0 to the 500 is 500 meters, and from 0 to negative 400 is another 400 meters, for a total of 900 meters. So 500 meters is 900 meters higher than negative 400 meters. C. What is the change in elevation from 8,500 meters to 3,400 meters? That went down in elevation, so we know that the change is going to be negative. We can write this expression as 8,500 minus 3,400, and that equals a difference of 5,100 meters. The change in elevation from 8,500 meters down to 3,400 meters is minus or negative 5,100 meters. D. What is the change in elevation between 8,500 meters and negative 300 meters? Again, this change in elevation went down, so we know the answer is going to be a negative. 8,500 minus negative 300. That's the same as 8,500 and the opposite of negative 300. The opposite of negative 300 is positive 300. So we can rewrite this as 8,500 plus 300, which equals 8,800 meters. So the change in elevation between 8,500 meters and negative 300 meters is a negative or a minus 8,800 meters. E. How much higher is negative 200 meters than 450 meters? We know that negative 200 meters is not higher than 450 meters, so we know this answer is going to be a negative. The absolute value of negative 200 plus the absolute value of 450 equals 650. So we knew the answer was going to be a negative, so we can say that negative 200 meters is negative 650 meters higher than 450 meters. Problem number 4. The table shows 4 transactions and the resulting account balance in a bank account, except some numbers are missing. Fill in the missing numbers. We could say that for the first transaction they started with 0 and they put in $360, or we can say that they started with $360 and withdrew $0. Either way, the account balance is $360. The second transaction, they withdraw $22.50. That means we need to subtract $22.50 from $360. That leaves us with the new account balance at $337.50. For transaction number 3, we end up with an account balance of $182.35. We can subtract $182.35 from the previous balance, $337.50. And the difference is $155.15. That means that the transaction was a withdrawal of $155.15. The account balance after transaction number 3 is $182.35. Then in transaction number 4, they must have withdrawn too much money because their account balance for transaction 4 is in the negatives. It's at negative $41.40. $182.35 minus a negative $41.40. Minus a negative is just like the opposite of a negative. So we can add $41.40 to $182.35, and that tells us how much they withdrew from the account. They withdrew $223.75. Let's take a look at an illustration that shows the difference between $182.35 and negative $41.40. To take the account balance from $182.35 all the way down to negative $41.40, they would withdraw or subtract $223.75. Problem number 5. The departure from the average is the difference between the actual amount of rain and the average amount of rain for a given month. The historical average for rainfall in Albuquerque, New Mexico for June, July, and August is shown in the table. A. Last June, only 0.17 inches of rain fell all month. What is the difference between the average rainfall and the actual rainfall for last June? The difference between 0.67 and 0.17 is 0.50 or 0.5 or a half inch. B. The departure from the average rainfall last July was negative 0.36 inches. How much rainfall fell last July? 1.5 inches minus 0.36 of an inch equals 1 1400 inches. Last July, there was 1 1400 inches of rain. C. How much rain would have to fall in August so that the total amount of rain equals the average rainfall for these 3 months? What would the departure from the average be in August in that situation? The departure from the average in June was negative 0.5 inches, and for July, the departure from the average was 0.36 inches. For those 2 months, it was a total of negative 0.86. That means that it's going to have to rain 86 hundredths of an inch more than the average in August to equal the average rainfall for these 3 months. The departure from the average will be 86 hundredths inches. The total amount of rain that needs to fall in August so that the amount of rain equals the average rainfall for all 3 months is 2.43 inches. That's 86 hundredths more than the average in August of 1.57.
Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 5, Representing Subtraction. Problem number 1. Write each subtraction equation as an addition equation. A minus 9 equals 6. We can rewrite that as A plus minus 9 equals 6. A equals 6 plus 9, or A equals 9 plus 6. B, P minus 20 equals negative 30. We can rewrite that as P plus a negative 20 equals negative 30, or P equals negative 30 plus 20, or P equals 20 plus a negative 30. C, Z minus a negative 12 equals 15. We could rewrite that as Z and the opposite of negative 12, which is positive 12, equals 15. Or Z equals 15 plus a negative 12, or Z equals negative 12 plus 15. D, X minus a negative 7 equals negative 10. We can rewrite that as X and the opposite of negative 7, which is a positive 7, equals negative 10. Or X equals negative 10 plus negative 7, or X equals negative 7 plus a negative 10. Problem number 2. Find each difference. If you get stuck, consider drawing a number line diagram. A, 9 minus 4. That's a difference of 5. B, 4 minus 9. That's a difference of negative 5. C, 9 minus a negative 4. That's like 9 and the opposite of negative 4. And the opposite of negative 4 is positive 4, so we can rewrite it as 9 plus 4, and that equals 13. D, negative 9 minus a negative 4. That's like a negative 9 and the opposite of negative 4. The opposite of negative 4 is positive 4, so we can write this as negative 9 plus 4, and that equals negative 5. E, negative 9 minus 4. That's like a negative 9 plus a negative 4 for a total of negative 13. F, 4 minus a negative 9. That's like 4 and the opposite of negative 9. And the opposite of negative 9 is positive 9. So we can rewrite this as 4 plus 9 equals 13. G, negative 4 minus a negative 9. That's like negative 4 and the opposite of negative 9. And the opposite of negative 9 is a positive 9. Negative 4 plus 9 is 5. We could rearrange the first two terms as 9 minus 4 equals 5. That makes it easier. H, negative 4 minus 9. That's like negative 4 plus minus 9, or negative 4 and negative 9. And that equals a total of negative 13. Problem number 3 from 7th grade, Unit 4, Lesson 10. A restaurant bill is $59 and you pay $72. What percentage gratuity did you pay? A gratuity is a tip. If the bill was $59 and you paid $72, the difference is $13. So the question is, what percentage of $59 is $13? 13 divided by 59 is 22 hundredths, and 22 hundredths is 22%. So the gratuity was 22%. Problem number 4. Find the solution to each equation mentally. A. 30 plus A equals 40. 30 plus what number equals 40? 30 plus 10 equals 40. A equals 10. 500 plus B equals 200. 500 plus what number equals 200? 500 plus a negative 300 equals 200. B equals negative 300. C. Negative 1 plus C equals negative 2. Negative 1 plus what number equals negative 2? Negative 1 plus a negative 1 equals negative 2. C equals negative 1. D. D plus 3,567 equals 0. What number plus 3,567 equals 0? Negative 3,567 plus 3,567 equals 0. D equals negative 3,567. Problem number 5 from 7th grade, Unit 2, Lesson 3. 1 kilogram is 2.2 pounds. Complete the tables. What is the interpretation of the constant of proportionality in each case? 2.2 pounds divided by 2.2 equals 1 kilogram. 11 divided by 2.2 equals 5 kilograms. 5.5 pounds divided by 2.2 equals 2.5 kilograms. And 1 pound divided by 2.2 equals 0.45 repeating kilograms. That turns out to be 0.45 repeating kilograms per pound. 1 kilogram times 2.2 equals 2.2 pounds. 7 kilograms times 2.2 equals 15.4 pounds. 30 kilograms times 2.2 equals 66 pounds. And 0.5 kilograms times 2.2 equals 1.1 pound. This is 2.2 pounds per kilogram. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 6, Subtracting Rational Numbers. Problem number 1. Write a sentence to answer each question. A. How much warmer is 82 than 40? 82 is 42 degrees warmer than 40. B. How much warmer is 82 than negative 40? Here you can see that there's 122 units between negative 40 and 82. 82 is 122 degrees warmer than negative 40. Problem number 2 from 7th grade, Unit 2, Lesson 8. A company produces screens of different sizes. Based on the table, could there be a relationship between the number of pixels and the area of the screen? If so, write an equation representing the relationship. If not, explain your reasoning. 6 square inches of screen times 5,184 equals 31,104 pixels. For this table, the number of square inches of screen multiplied by the same number, 5,184, equals the number of pixels on each screen. Yes, it is proportional. P represents the number of pixels, and A is the area of the screen in square inches. P equals 5,184A. The constant of proportionality would be 5,184 because you're constantly multiplying 5,184 times the area of the TV screen to find out how many pixels would be on the TV screen. Problem number 3. A. What is the difference in height between 30 meters up a cliff and 87 meters up a cliff? What is the distance between these positions? The difference in height between 30 meters up a cliff and 87 meters up a cliff is negative 57 meters because 30 minus 87 equals negative 57. The distance between these two positions is 57 meters because the absolute value of negative 57 is 57. B. What is the difference in height between an albatross flying at 100 meters above the surface of the ocean and a shark swimming 30 meters below the surface? What is the distance between them if the shark is right below the albatross? This illustration shows a clear picture that the distance between the albatross and the shark is 130 meters. The difference in height between the albatross and the shark is 130 meters because 100 minus a negative 30 is the same as 100 and the opposite of negative 30. And the opposite of negative 30 is positive 30. 100 plus 30 equals 130. The distance between them is 130 meters because the absolute value of 130 is 130. Problem number 4. Find each difference. A. Negative 5 minus 6. That's like 5 negatives and 6 negatives for a total of 11 negatives, or negative 11. B. 35 minus negative 8. That's like 35 and the opposite of negative 8. Since the opposite of negative 8 is positive 8, we can rewrite this as 35 plus 8, and that equals 43. C. 2/5 minus 3/5. That equals negative 1/5, because 2 minus 3 is negative 1. D. Negative 4 and 3/8 minus negative 1 and 1/4. That's the same as negative 4 and 3/8 and the opposite of negative 1 and 1/4. Since the opposite of negative 1 and 1/4 is positive 1 and 1/4, we can add these two mixed numbers. I'm using 8 as the common denominator, so the expression reads negative 4 and 3/8 plus 1 and 2/8. Negative 4 plus 1 is negative 3, and negative 3/8 plus 2/8 is negative 1/8. So the difference for D is negative 3 and 1/8. Problem number 5. From 7th grade, Unit 4, Lesson 10. A family goes to a restaurant. When the bill comes, this is printed at the bottom of it. Gratuity guide for your convenience. 15% would be $4.89. 18% would be $5.87. And 20% would be $6.52. How much was the price of the meal? Explain your reasoning. To find the price of this meal, we can ask 15% of what number equals $4.89. We can rewrite this as 0.15 times n equals 4.89. Now all we have to do is solve for n by dividing both sides by 0.15. N equals 32.60. That means that the price of the meal was $32.60. Problem number 6 from 7th grade, Unit 1, Lesson 2. Which is a scaled copy of polygon A? Identify a pair of corresponding sides and a pair of corresponding angles. Compare the areas of the scaled copies. First, let's identify these 90-degree angles on all the polygons. They asked us to find the scaled copy of polygon A. So first, let's look at the dimensions of polygon A. This horizontal side length on top is 1 unit in length. This vertical side length is 5 units in length. This horizontal side length at the bottom is 3 units in length. This vertical side length on the bottom right is 1 unit in length. This horizontal side length is 2 units in length. And this vertical side length is 4 units in length. Let's compare these side lengths with the corresponding side lengths of the other polygons. Since we're looking for a scaled copy, all the angles have to be the same angle and the side lengths have to increase or decrease proportionally. Polygon B doesn't look right. That can't be a scaled copy because some side lengths doubled when other side lengths didn't increase at all. So we can't choose polygon B. Let's look at the rest of the polygons. All the side lengths in polygon D doubled in length. That means that all the side lengths increase proportionally. So we can choose polygon D as a scaled copy of polygon A. None of the other polygons had all their side lengths increase proportionally. So we can't pick any of the other polygons as being a scaled copy of polygon A.
7th grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 8, Position, Speed, and Direction. Problem number 1. A number line can represent positions that are north and south of a truck stop on a highway. Decide whether you want positive positions to be north or south of the truck stop. Then, plot the following positions on a number line. A. The truck stop. Here's an illustration of a number line with the truck stop, A, placed at 0. B. 5 miles north of the truck stop. 5 miles north of the truck stop. Let's put north as positive, so B, 5 miles, would be located to the right of the truck stop. C. 3.5 miles south of the truck stop. South would be negative, which would be located to the left of the truck stop. I've placed the points on the number line. The point for A is at 0, representing the truck stop. The point for B is at positive 5 miles, representing 5 miles north of the truck stop. And the point for C is at negative 3.5, representing 3.5 miles south of the truck stop. Problem number 2. A. How could you distinguish between traveling west at 5 miles per hour and traveling east at 5 miles per hour without using the words east and west? By giving west 5 miles per hour a negative sign and the east 5 miles per hour a positive sign. B. 4 people are cycling. They each start at the same point. 0 represents their starting point. Plot their finish points after 5 seconds of cycling on a number line. Lynn cycles at 5 meters per second. So if Lynn travels at 5 meters per second, that's 5 meters times 5 seconds, Lynn would travel 25 meters. See the number line below, I have Lynn plotted at 25 to the right of 0. Diego cycles at negative 4 meters per second. Initially that sounds kind of strange, but this could mean that Diego cycles 4 meters to the west per second. Negative 4 times 5 would be negative 20. So look at the number line and you can see that I've plotted Diego's ride at the negative 20, which is to the left of 0 on the number line. Elena cycles at 3 meters per second. That's positive, so that's going to be to the right of 0 on the number line. And 3 meters times 5 equals 15. So I'll plot this point at positive 15 to the right of 0 on the number line. Noah cycles at negative 6 meters per second. That's like Noah cycles 6 meters to the west per second. Negative 6 times 5 equals negative 30. So I'm going to plot Noah at negative 30 to the left of 0 on the number line. Problem number 3 from 7th grade, Unit 5, Lesson 6. Find the value of each expression. 16.2 plus negative 8.4. That's the same as 16.2 and take away 8.4. So we can write it like this, 16.2 minus 8.4. And the value of this expression is 7.8, or 7 8/10. Negative 9.2 plus negative 7. That's just like negative 9.2 and another negative 7. So we're really adding two groups of negatives. Negative 9.2 plus negative 7. That's a total of negative 16.2. So the value for this expression is negative 16.2. Positive 2/5 minus 3/5. That's like having 2/5 to the right of 0 on the number line and then moving 3/5 to the left. And that would take us to negative 1/5 on the number line. Another way to think about it, they both have 5 as the denominator. So we know the answer is going to have a 5 as the denominator. And then we can just subtract 3 from 2. And 2 minus 3 is negative 1. So we know the answer is going to be negative 1 over 5. Negative 4 3/8 minus a negative 1 1/4. Remember, minus a negative, that's like saying the opposite of a negative. So we can rewrite this as negative 4 3/8 plus 1 1/4. Let's make the common denominator 8. 4 times 2 is 8. Since we multiplied the bottom number by 2, we need to multiply the top number by 2. And 1 times 2 is 2. So now this reads negative 4 3/8 plus 1 2/8. Since the absolute value of negative 4 3/8 is greater than the absolute value of 1 2/8, we know the answer is going to be a negative. So we can just subtract and then write that difference as a negative. 4 minus 1 is 3, and 3/8 minus 2/8 is 1/8. So the difference is 3 1/8. But remember, the answer is going to be negative, so the value of this expression is negative 3 1/8. Problem number 4 from 7th grade, Unit 4, Lesson 10. A shopper bought a watermelon, a pack of napkins, and some paper plates. In his state, there is no tax on food. The tax rate on non-food items is 5%. The total for the 3 items he bought was $8.25 before tax, and he paid 19 cents in tax. How much did the watermelon cost? There was no tax on the watermelon, plus there was 5% tax for the napkins, and another 5% tax on the paper plates. Before tax, that totals $8.25, plus an additional 19 cents in tax. That 19 cents represents the 5% total tax on the napkins and the paper plates. We can find the total price of the napkins and the paper plates by asking this question. What number times 5% equals 0.19? And the equation is n times 0.05 equals 0.19 because 5% as a decimal is 0.05. Next, we solve for n by dividing both sides by 0.05. And n equals 3.8. That means the total price for the napkins and the paper plates is $3.80. We can find the price of the watermelon by subtracting this $3.80 from the total price of the bill, which was $8.25. So $8.25 minus $3.80 equals $4.45. The price of the watermelon was $4.45. Problem number 5 from 7th grade, Unit 5, Lesson 5. For each equation, write 2 more equations using the same numbers that express the same relationship in a different way. A. 3 plus 2 equals 5. Let's use the same numbers and write down 2 more equations. 2 plus 3 equals 5, and 2 equals 5 minus 3. We could do one more. Let's do 3 equals 5 minus 2. B. 7.1 plus 3.4 equals 10.5. 3.4 plus 7.1 equals 10.5. This shows that the order of addition doesn't matter. 10.5 minus 7.1 equals 3.4. Even though they only ask for 2 more, let's do another one. 10.5 minus 3.4 equals 7.1. C. 15 minus 8 equals 7. Negative 8 plus 15 equals 7. 7 minus 15 equals negative 8. Let's do one more. 7 plus 8 equals 15. D. 3 halves plus 9 fifths equals 33 tenths. Remember, for addition, the order doesn't matter, so we can rewrite this as 9 fifths plus 3 halves equals 33 tenths. We can also write 33 tenths minus 9 fifths equals 3 halves. And another equation would be 33 tenths minus 3 halves equals 9 fifths. Problem number 6, from 7th grade, Unit 2, Lesson 10. Which graphs could not represent a proportional relationship? Explain how you decided. A has a straight line that starts at the origin, so A represents a proportional relationship. C is a straight line that starts at the origin. That represents a proportional relationship. Graph B has a curved line, so that does not represent a proportional relationship, even though it starts at the origin. Graph D is also not proportional because it doesn't start from the origin and it doesn't go through the origin. 7th grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 9, Multiplying Rational Numbers. Problem number 1. Fill in the missing numbers in these equations. A. Negative 2 times negative 4.5 equals, a negative times a negative equals a positive, and 2 times 4.5 is 9. So negative 2 times negative 4.5 equals 9. B. Negative 8.7 times negative 10. Once again, a negative times a negative is a positive, and 8.7 times 10 is going to be 10 times bigger than 8.7, or 87. C. Negative 7 times what number equals 14? So a negative times a negative is a positive, so the unknown number must be a negative. 7 times 2 is 14, so negative 7 times negative 2 equals positive 14. D. What number times negative 10 equals 90? Again, a negative times a negative equals a positive, and 9 times 10 equals 90. So negative 9 times negative 10 equals 90. Problem number 2. A weather station on top of a mountain reports that the temperature is currently 0 degrees Celsius and has been falling at a constant rate of 3 degrees Celsius per hour. Find each temperature. Explain or show your reasoning. A. If it continues to fall at this rate, what will the temperature be in 2 hours? 2 times negative 3 is negative 6, so we can subtract 6 from 0. The temperature in 2 hours would be negative 6 degrees Celsius. What would the temperature be in 5 hours? 5 times negative 3 is negative 15. So 0 degrees minus 15 degrees would be negative 15 degrees Celsius. What would the temperature be in a half an hour? A half an hour, or 0.5 times negative 3 equals negative 1.5. After a half an hour, the temperature would be negative 1.5 degrees Celsius. B. What was the temperature 1 hour ago? 1 hour ago can be represented as negative 1. So we can write negative 1 times negative 3. That equals positive 3. So an hour ago, the temperature would be 3 degrees Celsius. What was the temperature 3 hours ago? 3 hours ago is negative 3 times negative 3 degrees for each hour, and that equals positive 9. 3 hours ago, the temperature was 9 degrees Celsius. What was the temperature 4.5 hours ago, or 4.5 hours ago? Since the order of multiplication doesn't matter, we can multiply negative 3, as in the negative 3 degrees Celsius, times negative 4.5, as in 4.5 hours ago. And that tells us that 4.5 hours ago, the temperature would have been 13.5 degrees Celsius, or 13.5 degrees Celsius. Problem number 3. Find the value of each expression. A. 1/4 times negative 12. Since this is a positive number times a negative number, we know the answer is going to be negative. And 1/4 of 12, or 12 divided by 4, is 3. So 1/4 of negative 12 is negative 3. B. Negative 1/3 times 39. This is a negative times a positive, so we know the answer is going to be a negative. And 1/3 of 39 is 13, or 39 divided by 3 is 13. So negative 1/3 of 39 is negative 13. C. Negative 4/5 times negative 75. This is a negative times a negative, so we know that the answer is going to be positive. Let me walk you through this one. 5 divided by 5 is 1, and negative 75 divided by 5 is negative 15. So we can rewrite this as negative 4 times negative 15. Once again, a negative times a negative is a positive, and 4 times 15 is 60. So negative 4/5 of negative 75 is positive 60. D. Negative 2/5 times negative 3/4. We can cross cancel. 2 divided by 2 is 1. 4 divided by 2 is 2. We can rewrite this as negative 1/5 times negative 3/2. The negative times a negative is a positive. 1 times 3 is 3 on top, and 5 times 2 is 10 on the bottom, for a positive 3/10. E. 8/3 times negative 42. This time we have a positive times a negative, so we know the answer is going to be negative. We could also cross cancel if we want. 3 divided by 3 is 1, and negative 42 divided by 3 is negative 14. We can rewrite this as 8 times negative 14. So a positive times a negative is a negative, and 8 times 14 is 112. So the value of this expression is negative 112. Problem number 4, from 7th grade, Unit 4, Lesson 2. To make a specific hair dye, a hairstylist uses a ratio of 1 1/8 ounce of red tone, 3/4 ounce of gray tone, and 5/8 ounce of brown tone. A. If the stylist needs to make 20 ounces of dye, how much of each dye color is needed? First, we can add up the red, the gray, and the brown tones. 1 1/8 plus 3/4 plus 5/8. Let's use 8 as a common denominator. 4 times 2 is 8, and 3 times 2 is 6. So 3/4 becomes 6/8. Let's take the whole 1, and then we can add up the rest of the eighths. Let's add the numerators. 1 plus 6 plus 5. That equals 12/8. So altogether we have 1 and 12/8, which is the same thing as 1 plus 12/8. And 12/8 can be simplified to 1 and 4/8, which can also be simplified to 1 and 1/2. The total of all three tones, 2.5 ounces, or 2.5 ounces. Since 2.5 ounces goes into 20 ounces 8 times, to make 20 ounces of dye, the stylist would need to multiply each ratio times 8. 1 1/8 of red dye times 8, or 1 1/8 of 8. That's also the same as 9/8 times 8. Since 9/8 times 8 is 9, the stylist would have to use 9 ounces of red tone when making 20 ounces of dye. 3/4 times 8, which is also equivalent to 6/8 of 8, or 6/8 times 8. Think of it as 6 times 8 divided by 8. That equals 6. So the stylist would have to use 6 ounces of gray tone when making 20 ounces of dye. 5/8 ounces of brown tone times 8. Again, we can think of this as 5 times 8 divided by 8, or 5 divided by 8 times 8. That equals 5. When making 20 ounces of dye, the stylist needs to use 5 ounces of brown tone. B. If the stylist needs to make 100 ounces of dye, how much of dye color is needed? Since 100 ounces is 5 times larger than 20 ounces, the stylist would have to use 5 times the amount of dye color than they did when they were making 20 ounces of dye. 9 ounces of red times 5 equals 45 ounces of red. 6 ounces of gray times 5 equals 30 ounces of gray. 5 ounces of brown times 5 equals 25 ounces of brown. Problem number 5 from 7th grade Unit 5, Lesson 7. Here are the vertices of rectangle FROG. Find the perimeter of this rectangle. If you get stuck, try plotting the points on a coordinate plane. I've drawn a rectangle and I've labeled the vertices FROG, and I've also labeled each of their coordinates. I can use these coordinates to help me find the number of units between each vertice, and that'll tell me each side length. The difference of the y coordinates for F and R is 4, so that side length is 4. And the difference of the x coordinates for R and G is 8, so that side length is 8 units. To find the perimeter, we can add up all the side lengths. There are 2 side lengths with the length of 4 units, and 2 side lengths with the length of 8 units. 4 plus 4 and 8 plus 8 is 24 units. The perimeter of this rectangle is 24 units. B. Find the area of the rectangle FROG. 4 units times 8 units equals 32 square units, or 32 units squared. C. Here are the coordinates of rectangle PLAY. Find the perimeter and the area of this rectangle. See if you can figure out its side lengths without plotting the points. The horizontal difference between -11 and 20 and -11 and -3 is 0, but the vertical difference is 23. The horizontal difference between -11 and 20 and -1 and 20 is 10, but the vertical difference is 0. The perimeter would be 23 plus 10 plus 23 plus 10, which is equal to 66 units. To find the area, you'd multiply 23 times 10, and that equals 230 square units. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 10, Multiply. Problem number 1. Evaluate each expression. A. -12 times 1/3. That's the same as 1/3 of -12, or -12 divided by 3. The value of this expression is -4. B. -12 times -1/3. That's the same as -1/3 of -12, or -12 divided by -3. A negative times a negative, or a negative divided by a negative, is a positive. So the value of this expression is +4. C. 12 times -5/4. We could cross cancel if we want. 4 divided by 4 is 1. 12 divided by 4 is 3. And we can rewrite this expression as 3 times -5. And the value for this expression is -15. D. -12 times -5/4. This is almost exactly the same as the last one, except for this is a negative times a negative, so the answer is going to be a positive. We can cross cancel again. 4 divided by 4 is 1. -12 divided by 4 is -3. And we can rewrite the expression as -3 times -5. So negative times a negative is a positive, and 3 times 5 is 15, so the value for this expression is +15. Problem number 2. Evaluate each expression. A. -1 times 2 times 3. We can do 2 times 3 to get 6, and then -1 times 6. That equals -6. The value for this expression is -6. B. -1 times -2 times 3. We can do -2 times 3 to get -6, and then -1 times -6. That's a negative times a negative, which equals a positive. So negative 1 times negative 6 equals positive 6. The value for this expression is positive 6. C. Negative 1 times negative 2 times negative 3. We can do negative 2 times negative 3 to get a positive 6, and then we can multiply negative 1 times positive 6. That equals negative 6. The value for this expression is negative 6. Problem number 3 from 7th grade, Unit 5, Lesson 1. Order each set of numbers from least to greatest. Let's look at the numbers in Group A. We'll start with the negative numbers with the highest absolute value, and that would be negative 6. The next largest number would be negative 2. The next number would be 0 since we ran out of negative numbers. Now we're looking for the smallest of the positive numbers. That would be 4. And then finally the largest number, or the number with the greatest value, is 8. Now let's look at the set of numbers in Group B. Let's look for the negative number with the largest absolute value. That would be negative 5.5. That's also equivalent to negative 5.5. The next smallest number is negative 5.2. We have negative 5, and then we have the fraction negative 5 halves, which is equivalent to negative 2.5. Now we're looking for the smallest of the positive numbers, 5.5, and that's the only positive number. So this is a look at set B from least to greatest. Problem number 4 from 7th grade, Unit 5, Lesson 3. 30 plus negative 30 equals 0. A. Write another sum of two numbers that equals 0. Negative 2 plus 2 equals 0. B. Write a sum of three numbers that equals 0. 5 plus negative 2 plus negative 3 equals 0. C. Write a sum of four numbers that equals 0, none of which are opposites. 2 plus 3 plus negative 1 plus negative 4 equals 0. Problem number 5 from 7th grade, Unit 5, Lesson 6. A submarine is searching for underwater features. It is accompanied by a small aircraft and an underwater robotic vehicle. At one time, the aircraft is 200 meters above the surface. The submarine is 55 meters below the surface, and the underwater robotic vehicle is 227 meters below the surface. A. What is the difference in height between the submarine and the aircraft? That would be 200 meters minus negative 55 meters. The distance between the two would be 255 meters. B. What is the difference between the underwater robotic vehicle and the submarine? Negative 55 meters minus a negative 227 meters. The difference between the underwater robotic vehicle and the submarine is 172 meters. Problem number 6 from 7th grade, Unit 5, Lesson 8. A. Claire is cycling at a speed of 12 miles per hour. If she starts at a position chosen as 0, what will her position be after 45 minutes? We can make a chart. On the left-hand column, we can put miles, and on the right-hand column, we can put minutes. Let's start with the information they gave us. Claire is traveling 12 miles per hour, and an hour's 60 minutes. 60 is 5 times larger than 12. In other words, 12 times 5 equals 60, or 60 divided by 5 equals 12. This tells me that the number of miles times 5 gives me the number of minutes, or the number of minutes divided by 5 gives me the number of miles. For example, 1 minute divided by 5 equals a distance of 1/5 of a mile, or 2/10 of a mile. Now let's answer their question, and we can start by putting 45 minutes in the right-hand column. 45 minutes divided by 5 equals 9. So it would take Claire 45 minutes to travel 9 miles. B. Han is cycling at a speed of -8 miles per hour. If he starts at the same 0 point, what will his position be after 45 minutes? Remember, -8 miles per hour could really represent a direction that he's traveling. So Han could be traveling 8 miles per hour west, compared to Claire, who may have been traveling east. Again, we can answer this by creating a chart with miles on the left and minutes on the right. They tell us that Han's traveling -8 miles per hour and there's 60 minutes in an hour. Working from the right side to the left side, 60 minutes divided by -7.5 equals -8, or 60 divided by -8 equals -7.5. This tells me that 1 minute of riding divided by -7.5 equals -0.13 miles. 1 times 45 equals 45 minutes, and -0.13 times 45 equals -6. So in 45 minutes, Han rides -6 miles, which could mean 6 miles to the west. C. What will the distance between them be after 45 minutes? Well, if Claire rides 9 miles in the positive direction and then Han rides 6 miles in the negative direction, that's going to be a total of 15 miles between them. Think of it as the absolute value of +9 plus the absolute value of -6. Problem number 7 from 7th grade Unit 5, Lesson 9. Fill in the missing numbers in these equations. A. -7 times what number equals -14? Well, 7 times 2 equals 14, and a negative times a positive equals a negative. So -7 times +2 equals -14. B. What number times 3 equals -15? A negative times a positive equals a negative, and 5 times 3 equals 15. So -5 times +3 equals -15. C. What number times 4 equals 32? So that's going to be a positive times a positive, since the answer is a positive, and the 4 is a positive. 8 times 4 equals 32. You can also find that by doing 32 divided by 4. That equals 8. D. -49 times 3 equals what number? Well, that's a negative times a positive, so you know the answer is going to be a negative. And 49 times 3 is 147. So the answer is -147. Seventh grade Open Up Resources, Illustrative Mathematics. Unit 5, Lesson 11, Dividing Rational Numbers. Problem number 1. Find the quotients. For this first one, we have a positive divided by a negative, so we know the answer is going to be a negative. 24 divided by -6 equals -4. The next one is a negative divided by a positive, so this quotient will also be a negative. -15 divided by 3/10 equals -50. Next, we have a negative divided by a negative, so we know that the quotient is going to be a positive. -4 divided by -20 is going to be a positive 1/5, which is also equivalent to positive 2/10. Problem number 2. Find the quotients. A. 2/5 divided by 3/4. We can change this to a multiplication problem by multiplying 2/5 by the reciprocal of 3/4. So now we have 2/5 times 4/3, which equals 18/15. B. 9/4 divided by -3/4. This is a positive divided by a negative. That means the quotient will be negative. And we can change this to a multiplication problem by multiplying 9/4 times the reciprocal of -3/4. Now it reads 9/4 times 4 over -3. We could simplify this by cross-canceling. On the left side, 4 goes into 4 once, and on the right side, 4 goes into 4 once. 3 goes into 9 3 times, and 3 goes into -3 -1 time. Multiply across the top, 3 times 1 is 3. Multiply across the bottom, you have 1 times negative 1, which is negative 1. And 3 over negative 1, or 3 divided by negative 1, is negative 3. C. This is a negative divided by a negative, so the quotient's going to be positive. We can change this to a multiplication problem by multiplying negative 5/7 by the reciprocal of negative 1/3. Which is 3 over negative 1. Negative 5 times 3 is negative 15 over 7 times negative 1. That's negative 7. Negative divided by a negative is a positive, so the quotient is 15 over 7. D. This is a negative divided by a positive, so the quotient's going to be a negative. We can change this to a multiplication problem by multiplying by the reciprocal of 1/6. That would be 6 over 1. We can do some cross-canceling. 3 goes into 3 once, and 3 goes into 6 twice. Now we have negative 5 times 2 over 1 times 1. That would be negative 10 over 1, which is equivalent to negative 10 divided by 1, which is equal to negative 10. Problem number 3. Is the solution positive or negative? A. 2 times what number equals positive 6? Since a positive times a positive equals a positive, then x must be positive. B. A negative times what number equals a positive? Since a negative times a negative equals a positive, then x must be negative. C. A positive times what number equals a negative? Since a positive times a negative equals a negative, then x must be negative. D. A negative times what number equals a negative? Since a negative times a positive equals a negative, then x must be positive. Problem number 4. Find the solution mentally. A. 3 times negative 4 equals A. Since a positive times a negative equals a negative, and 3 times 4 is 12, then A must equal negative 12. B. B times negative 3 equals negative 12. Since a positive times a negative equals a negative, and 4 times 3 is 12, then B must be positive 4. I can also work this problem backwards and divide. Negative 12 divided by negative 3 equals positive 4, so B equals positive 4. C. Negative 12 times what number equals positive 12? Since a negative times a negative equals a positive, and 12 times 1 is 12, then the value for C must be negative 1. D. D times 24 equals negative 12. Well, we know that a negative times a positive equals a negative, so D must be negative, and half of 24 is 12. So negative 1/2 times positive 24 equals negative 12. D equals negative 1/2. Problem number 5 from 7th grade Unit 4, Lesson 2. In order to make a specific shade of green paint, a painter mixes 1½ quarts of blue paint, 2 cups of green paint, and a ½ gallon of white paint. How much of each color is needed to make 100 cups of this shade of green? The secret to answering this question is make all the units of measure cups. The painter originally started with 1½ quarts of blue paint. That's equal to 6 cups. That means that he started with 6 cups of blue paint. The information provided also tells us that the painter started with 2 cups of green paint. Since there are 16 cups in 1 gallon, that means that there's 8 cups in a ½ a gallon. That means that the painter started with 8 cups of white paint. Let's add up all these cups of paint. 6 cups of blue paint plus 2 cups of green paint plus 8 cups of white paint equals 16 cups total for his first batch. To make a batch of 100 cups of paint, multiply each color amount by 6 1/4, because 100 is 6 1/4 times greater than 16. Originally, he had 16 cups. Now he's going to make a batch with 100 cups. In his first batch, The painter started with 6 cups of blue paint. We need to multiply those 6 cups by 6.25. That means for the batch of 100 cups of paint, the painter is going to need 37.5 cups of blue paint. In the painter's first batch, he started with 2 cups of green paint. To make a batch of 100 cups, we need to multiply 2 cups of green paint times 6.25. That means the painter will need 12.5 cups of green paint, or 12.5 cups of green paint, to make a batch of 100 cups. And finally, that brings us to the amount of white paint. He started with his original batch with 8 cups of white paint. Now we need to multiply 8 cups of white paint times 6.25 so that he can make a batch with 100 cups of paint. Since 8 times 6.25 equals 50, the painter will need 50 cups of white paint to make the batch of 100 cups of paint. For the painter to make 100 cups of this shade of green paint, the painter will need 37.5 cups of blue paint, 12.5 cups of green paint, and 50 cups of white paint. Add up all these cups and you can see that it equals the 100 cups that make up this shade of green paint. Problem number 6 from 7th grade, Unit 5, Lesson 3. Here is a list of the highest and lowest elevation on each continent. A. Which continent has the largest difference in elevation? And which continent has the smallest difference in each elevation? Asia has the largest difference in elevation with a difference of 9,275 meters because 8,848 minus negative 427 is the same as 8,848 and the opposite of negative 427. And the opposite of negative 427 is positive, so 8,848 plus 427. That equals a difference of 9,275. Europe has the smallest difference in elevation because 4,810 minus a negative 28 is the same as 4,810 and the opposite of negative 28. And the opposite of negative 28 is positive 28. So 4,810 plus 28 equals a difference of 4,838. B. Make a display, dot plot, box plot, or histogram of the data set and explain why you chose that type of display to represent this data set. Take a close look at the right-hand column of the table. All 7 continents have a negative as their lowest point. We can easily represent that on a histogram or graph like this. The vertical axis represents the number of continents and the horizontal axis represents the highest and lowest point in meters. The red column on this graph represents all 7 continents. The lowest points of all the continents fall between 0 and negative 2,000 meters on this histogram. Now let's take a look at Asia's highest point. Its elevation is much higher than all of the others, so it can have its own place on the chart. On the histogram, it looks like this in orange. It's 1 unit high, which represents 1 continent, and that means that 1 continent has a high elevation of between 8,000 and 10,000 meters. Looking back at the table, you notice that North America and South America have very similar highest points in meters. On the histogram, we can go 2 units vertically. That represents 2 continents. On the horizontal line, it ranges from 6,000 meters to 8,000 meters in elevation. The highest elevation of these 4 continents are very close, so they'll be represented together in one column on the histogram like this. This column reaches a height of 4 units vertically. That represents 4 continents. And horizontally, it ranges from 4,000 to 6,000. That means that 4 of the continents have a highest elevation that falls between 4,000 and 6,000 meters. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 5, Lesson 12, Negative Rates. Problem number 1 from 7th grade, Unit 4, Lesson 3. A cookie recipe uses 3 cups of flour to make 15 cookies. How many cookies can you make with this recipe with 4 cups of flour? Assume you have enough of the other ingredients. The information tells us that 3 cups of flour makes 15 cookies. Let's find out how many cookies can be made with just 1 cup of flour. 3 divided by 3 equals 1 cup of flour, and 15 divided by 3 equals 5 cookies. With 1 cup of flour, you can make 5 cookies. Now we can find out how many cookies we can make with 4 cups. 1 times 4 equals 4 cups of flour, and 5 times 4 equals 20 cookies. So you can make 20 cookies with 4 cups of flour. B. A teacher uses 36 centimeters of tape to hang up 9 student projects. At this rate, how much tape would the teacher need to hang up 10 student projects? Let's see how much tape it takes to hang 1 project. 9 divided by 9 is 1, and 36 divided by 9 is 4. Now we can multiply 1 times 10 for 10 student projects, and 4 times 10, which gives us 40 centimeters of tape. To hang 10 projects, the teacher's going to need 40 centimeters of tape. Problem number 2 from 7th grade, Unit 5, Lesson 11. Evaluate each expression. When the answer is not a whole number, write your answer as a fraction. A. This is a negative times a negative, and we know that a negative times a negative is a positive, and 4 times 6 is 24. So negative 4 times negative 6 equals a positive 24. B. This is a negative times a negative, so we know the answer is going to be a positive. We can rewrite it as 24 over 1 times 7 over 6. And there's some cross-canceling we can do. 6 goes into 6 once, and 6 goes into 24 4 times. Now multiply straight across. 4 times 7 is 28. 1 times 1 is 1. 28 divided by 1 is 28. C. This is a positive divided by a negative, so we know the answer is going to be a negative. And 4 divided by 6, that's the same as 4 over 6. We can do some simplifying. 2 goes into 4 twice, and 2 goes into 6 3 times. 4 divided by negative 6 equals negative 2/3. D. 4/3 divided by negative 24. That's a positive divided by a negative, so we know the answer is going to be a negative. Now we can rewrite this part as 4/3 divided by 24 over 1. We can solve this by multiplying by the reciprocal of 24 over 1, which is 1 over 24. We can do some cross-canceling. 4 goes into 4 once, and 4 goes into 24 6 times. Now we can multiply straight across. 1 times 1 equals 1, and 3 times 6 equals 18. So the answer is negative 1 over 18. Problem number 3. Some boats were traveling up and down a river. A satellite recorded the movements of several boats. A motorboat traveled negative 3.4 miles per hour for 7/500 hours. How far did it go? Negative 3.4 times 0.75. That equals negative 2.55. So at that speed and that length of time, the motorboat was able to travel negative 2.55 miles. B. A tugboat traveled negative 1.5 miles in 0.3 hours. What is its velocity? Negative 1.5 divided by 0.3. That equals negative 5. The velocity of the tugboat was negative 5 miles per hour. C. What do you think that negative distances and velocities could mean in this situation? Negative distances could mean west, while positive would be east. Negative velocity could mean it was moving in the negative direction. Or negative velocity could mean the speed it is moving in the negative direction. Problem number 4. Describe a situation where each of the following quantities might be useful. A. Negative 20 gallons per hour. That might represent water draining out of a pool. B. Negative 10 feet per minute. That might represent a scuba diver descending. C, negative 1/10 kilograms per second. That might represent garbage dumped from a truck. Problem number 5. A submarine is only allowed to change its depth by rising towards the surface in 60-meter stages. It starts off at negative 340 meters. A. At what depth is it after one stage? The submarine starts out at negative 340 meters below the surface of the ocean, and it's allowed to go up 60 meters at a time towards the surface. After the first stage, it rises 60 meters. Negative 340 plus 60. That equals negative 280 meters. So after the first stage, the submarine is located at negative 280 meters, or 280 meters below the ocean's surface. At what depth is it after two stages? So now we need to rise up another 60 meters for its second stage. Negative 280 plus 60. That equals negative 220 meters, or 220 meters below the surface of the ocean. Finally, what's its location after 4 stages? So now we need to rise up 2 times 60, or rise up 120 meters. Negative 220 plus 120. That equals negative 100 meters. Or the submarine is located 100 meters below the surface of the ocean. B. How many stages will it take to return to the surface? Well, after 4 stages, it's located 100 meters below the surface. So let's start there at negative 100 meters. One more stage would be negative 100 plus 60. That equals negative 40 meters. Now we have room for one more stage. Plus 60 would get us well beyond the surface. To rise to the surface, the submarine would have had to use 6 stages of change. We can double check. 340 divided by 60 equals 5.7. 5 changes wouldn't have been enough. They would have had to have started a 6th change. Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 13, Expressions with Rational Numbers. Problem number 1 from 7th grade Unit 4, Lesson 3. A coffee maker's directions say to use 2 tablespoons of ground coffee for every 6 ounces of water. How much coffee should you use for 33 ounces of water? 2 tablespoons for every 6 ounces of water. That's a ratio of 2 to 6. 2 divided by 2 equals 1, and 6 divided by 2 equals 3. That's a ratio of 1 to 3. 1 tablespoon of coffee for every 3 ounces of water. The question asks, how many tablespoons of coffee for 33 ounces of water? 33 divided by 3 is 11, and 3 times 11 is 33. If we multiply the number of ounces of water by 11, then we can multiply the number of tablespoons by 11. 1 times 11 is 11. So when you're using 33 ounces of water, you'll need to use 11 tablespoons of coffee. B. A runner is running a 10-kilometer race. It takes her 17.5 minutes to reach the 2.5-kilometer mark. At that rate, how long will it take her to run the whole race? It takes her 17.5 minutes to run 2.5 kilometers. Let's use this information to help us find out how long it took to run 1 kilometer. 2.5 divided by itself equals 1. So we have 1 kilometer. Now we need to divide the other side by 2.5. 17.5 minutes divided by 2.5 equals 7 minutes. Well, we know that it takes 7 minutes to run 1 kilometer. They ask, how long will it take to run the whole race? And the whole race is 10 kilometers. 10 divided by 1 is 10. And 1 kilometer times 10 equals 10 kilometers. Now we need to multiply the minute side by 10. 7 minutes times 10 equals 70 minutes. At this rate, it'll take the runner 70 minutes to run 10 kilometers. Problem number 2 from 7th grade, Unit 4, Lesson 10. The price of an ice cream cone is $3.25, but it costs $3.51 with tax. What is the sales tax rate? $3.51 minus $3.25 is 26 cents. So the tax is 26 cents. And the question is, what is the sales tax rate? We need to ask this question. 26 cents is what percent of $3.25? 0.26 divided by 3.25. That equals 0.08 or 8/100ths, which is 8%. So the sales tax rate is 8% because the sales tax, 26 cents, is 8% of the price of the ice cream, $3.25. Problem number 3. Find the value of each expression. A. -22 plus 5. We certainly have more negatives than we do positives, so this answer is going to be a negative. And the difference between 22 and 5 is 17. So -22 plus 5 equals -17. B. -22 minus -5. I like to think of this as -22 and the opposite of -5. And the opposite of -5 is +5. So the value of this expression is the same as expression A, -22 plus 5. That equals -17. C. This is a negative times a negative, so we know the answer is going to be a positive. And 22 times 5, we could think of that as 20 times 5, which is 100, plus 2 times 5, which is 10. And 100 plus 10 is 110. So -22 times -5 equals positive 110. D. This is a negative divided by a positive, so we know the answer is going to be a negative. 22 divided by 5. We can think of that as 20 divided by 5, which is 4, plus 2 divided by 5, which is 2/5. So the value for this expression is -4 and 2/5, or -4 and 4/10. Problem number 4 from 7th grade, Unit 4, Lesson 7. Two students are both working on the same problem. A box of laundry soap has 25% more soap in its new box. The new box holds 2 kilograms. How much soap did the old box hold? Do you agree with either of them? Explain or show your reasoning. I agree with the way Lynn set up her double number line. The soap in the old box represents 100%, and the new box holds 25% more than that. 100% plus 25% equals 125%. The new box weighs 2 kilograms and is 125% more than the old box. Problem number 5. The value of x is -1/4. Order these expressions from least to greatest. Well, the information tells us that x is worth -1/4, so this x is worth -1/4. 1 minus x is the same as 1 minus -1/4, or 1 and the opposite of -1/4, which is +1 1/4. X minus 1 is the same as -1/4 minus 1. That has the same value as -1/4 plus -1, which has a value of -1 1/4. Finally, -1 divided by x. That's the same as -1 divided by -1/4. It's also a negative divided by a negative, so we know the answer is going to be a positive. We can find the value by multiplying 1 times the reciprocal of 1/4. That would be 1 times 4/1, or 1 times 4. In this case, -1 divided by x equals +4. Now, all we have to do is order them from least to greatest. X minus 1, x, 1 minus x, and -1 divided by x. Problem number 6. Here are four expressions that have the same value, -1/2. Write 5 expressions, a sum, a difference, a product, a quotient, and one that involves at least 2 operations that have the value -3/4. Let's start with an addition expression, -1 plus 1/4. That'll provide us with a sum that has the value of -3/4. For the difference, we'll use a minus sign in the expression, -1 minus a -1/4. That's similar to our first example with the plus sign because the opposite of a negative is a positive. -1 minus a -1/4 is the same as -1 plus 1/4. Next, we'll use a multiplication symbol, -1 times 3/4, and that also gives us a value of -3/4. For the quotient, we'll use the division symbol, -1 divided by 4/3. That's the same as -1 times the reciprocal of 4/3, which also has the value of -3/4. For this last one, we need to involve 2 operations. Let's involve division and subtraction. 1 divided by 4 minus 1. Since 1 divided by 4 is 1/4 and 1/4 minus 1 equals -3/4, this expression has the value of -3/4. Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 14, Solving Problems with Rational Numbers. Problem number 1 from 7th grade Unit 4, Lesson 11. A furniture store pays a wholesale price for a mattress. Then, the store marks up the retail price to 150% of the wholesale price. Later, they put the mattress on sale for 50% off of the retail price. A customer just bought the mattress on sale and paid $1,200. A. What was the retail price of the mattress before the discount? The customer paid $1,200 for the mattress and they got it for 50% off the retail price. $1,200 is 50% of $2,400, so the retail price was $2,400. B. What was the wholesale price before the markup? Since it was marked up 150%, we can ask what number times 150% equals 2,400. We can rewrite that as n times 1.5 equals 2,400. Next, solve for n by dividing both sides by 1.5. n times 1.5 divided by 1.5 equals n. And on the right side, 2,400 divided by 1.5 equals 1,600. So the wholesale price before the markup was $1,600. Problem number 2. The table shows transactions in a checking account. A. Find the total of transactions for each month. Let's start with January. They begin January with a withdrawal of $38.50. They put into the bank $126.30. That's a difference of $87.80. We can add that to the positive $429.40, and that new balance is $517.20. And then finally, we're going to take away another $265. And that gives us an ending balance for January of $252.20. Now let's look at the month of February. They start by depositing $250 and then a withdrawal where they subtracted $135.20 from their account, leaving a balance of $114.80. But then they deposited $35.50, making the account balance $150.30. And the last transaction in February was a withdrawal of $62.30, leaving them a February account balance of $88. Let's look at March. They start with a withdrawal of $14, followed by a deposit of $99.90, leaving a temporary balance of $85.90, another withdrawal of $82.70, leaving a temporary balance of just $3.20, and the last transaction was a withdrawal of $1.50, leaving the March balance at just $1.70. Last, let's look at the month of April. They start with a withdrawal of $86.80, followed by another withdrawal of $570, leaving a temporary balance of negative $656.80. Finally, they deposited $100. That brought the temporary balance up to negative $556.80, and then made a final withdrawal of $280.10, leaving the ending balance in April at a negative $836.90. B. Find the mean total for the 4 months. The mean total for the 4 months is negative $123.75, because $252.20 plus $88 plus $1.70 plus a negative $836.90 divided by 4 equals a negative $123.75. Problem number 3. A bank charges a service fee of $7.50 per month for a checking account. A bank account has $85. If no money is deposited or withdrawn except the service charge, how many months until the account balance is negative? We could think of this as 85 plus negative $7.50 times x equals 0. And in this case, x represents number of months. Now, all we have to do is solve for x. Subtract 85 from both sides. Now we're left with negative 7.5x equals negative 85. Divide both sides by negative 7.5, and x equals 11.3 repeating. That's more than 11 months. It would take 12 months before the account balance is negative. Problem number 4. A large aquarium of water is being filled with a hose. Due to a problem, the sensor does not start working until sometime into the filling process. The sensor starts its recording at the time 0 minutes. The sensor initially detects the tank has 225 liters of water in it. A. The hose fills the aquarium at a constant rate of 15 liters per minute. What will the sensor read at the time 5 minutes? Okay, the total amount of water is going to equal the rate of change times the number of minutes plus the initial amount of water. We can write the equation T equals 15 times 5 plus 225. The 15 represents the constant rate at which the water is being filled. The 5 represents the 5 minutes that you're filling the tank. And the plus 225 represents the number of liters that the sensor initially detected in the tank. And the T represents the total amount of water. After 5 minutes, the sensor would read 300 liters of water in the tank. B. Later, someone wants to use the data to find the amount of water at times before the sensor started. What should the sensor have read at the time negative 7 minutes? We can use the previous equation, but we'll substitute the 5 with a negative 7. Now we have T equals 15 times negative 7 plus 225. Since 15 times negative 7 equals negative 105, T equals 225 minus 105. So T equals 120. At the negative 7 minute mark, there should have been 120 liters in the tank. Problem number 5 from 7th grade, Unit 4, Lesson 10. A. A restaurant bill is $21. You leave a 15% tip. How much do you pay including the tip? It's $21 times a 15% tip. We can rewrite this as 21 times 0.15, which equals $3.15. So you'd leave a $3.15 tip. Add that to the price of the bill. The total amount paid, including the tip, would be $24.15. B. Which of the following represents the amount a customer pays including the tip of 15% if the bill was B dollars? Select all that apply. 15% of the bill plus the bill. We could rewrite that as 0.15 times B, representing 15% of the bill, plus B, representing the actual bill. The first part of this expression, 0.15 B, represents the tip, and then plus B, that represents the bill. 0.15 is also 15/100ths, and we can write 15/100ths as a fraction like this, 15 over 100. 15/100ths times B plus B. The order doesn't matter. We can also rewrite this as B plus 15/100ths B. This is a match with F. Let's go back to the 15/100ths written as a decimal. We have 0.15 B plus B. Again, we can rewrite the order, and we have B plus 15/100ths times B, or B plus 0.15 B. That's a match with C. This represents B times 0.15 plus B times 1. Since 0.15 plus 1 is 1.15, we can write this as B times 1.15. The order doesn't matter. We can multiply 1.15 times B, and it has the same value. This is a match with D. The only matches are C, D, and F. Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 15, Solving Equations with Rational Numbers. Problem number 1. Solve. A. 2/5 t equals 6. To make 2/5 x into 1x, we can multiply both sides by the reciprocal of 2/5, which is 5 over 2. On the left side of the equation, the value for t is 1. And on the right side of the equation, 3 times 5 equals 15 over 1 times 1. So 15 over 1 equals 15. So the value for t equals 15. B. Negative 4.5 equals a minus 8. To make the value of a 1a, we need to add 8 to both sides. Now the value on the right side is 1a, or a, and on the left side we have negative 4.5 plus 8. That's the same as 8 minus 4.5. which equals 3.5. The value for a is 3.5. C. 1/2 plus p equals negative 3. Let's go to the left side of the equal sign. We want to get the p by itself, so we have to subtract 1/2 from both sides. The left side, the value of p is 1p, or p, and on the right side we have negative 3 minus 1/2. That's a total of negative 3.5. The value for p is negative 3.5. D. 12 equals x times 3. To get the x by itself, we need to divide both sides by 3. The right side equals 1x, or x, and the left side of the equal sign is 12 divided by 3, which is 4. So in this case, the value of x is 4. E. Negative 12 equals negative 3y. To get the y by itself, we need to divide both sides by negative 3. Now the right side is equal to 1y, or y, and the left side is negative 12 divided by negative 3. A negative divided by a negative is a positive, and 12 divided by 3 is 4. So in this case, the value for y is positive 4. Problem number 2 from 7th grade, Unit 5, Lesson 13. Evaluate each expression if x is 2/5, y is negative 4, and z is negative 2/10 or negative 0.2. A. X plus y. Let's substitute these values. The value for x is 2/5, and the value for y is -4. So this equals 2/5 plus -4. Now, plus and -4 is the same thing as -4. So 2/5 minus 4. So -4 is the same as -4/1 as a fraction. We need common denominators, so let's multiply the 1 times 5 to make it a 5. When we do that, we also have to multiply the top number by 5. 4 times 5 equals 20. Now the equation reads 2/5 minus 20/5. The answer is going to be in fifths, and 2 minus 20 is -18. So 2/5 minus 20/5 equals -18/5. In this case, A, x plus y equals -18/5. We can also write this as a mixed number, and that would be -3 3/5. B, 2x minus z. Again, let's substitute the x with the 2/5. Now this means 2 times 2/5. And let's substitute the z with -0.2. Now this means minus -0.2, which is the same as the opposite of -0.2, which is a positive 0.2. Since 2 times 2/5 equals 4/5, we can rewrite this expression as 4/5 plus 2/10. In order to add fifths to tenths, we need to find a common denominator. Let's turn the fifths into tenths by multiplying it by 2, and we need to multiply the numerator by 2. 5 times 2 is 10, and 4 times 2 is 8, turning 4/5 into 8/10. Now we have 8/10 plus 2/10. We can write them both as decimals, or we can write them both as fractions and add them. Let's use decimals. You'll notice that I wrote 80 hundredths plus 20 hundredths. That has the same value as 8/10 plus 2/10. Kind of like how 8 dimes has the same value as 80 pennies, and 2 dimes has the same value as 20 pennies. 8/10 plus 2/10 equals 10/10 or 1 whole. So in this case, 2x minus z equals 1. C, x plus y plus z. Substitute the x with a 2/5, substitute the y with a -4, and substitute z with -2/10. Since the fraction 2/5 is equivalent to 4/10, we can rewrite this as 4/10 plus a -4 and plus a -2/10, which equals -3.8. So x plus y plus z equals -3 8/10. D, y times x. Let's substitute the y with a -4 and substitute the x with 2/5. This is a negative times a positive, so we know the answer is going to be a negative. Think of this as a -4/1. So we have this 4 times 2, that's an 8, and a 1 times 5, that's a 5. Remember, the answer is going to be a negative. Y times x equals -8/5. Problem number 3. Match each equation to a step that will help solve the equation. So for these, we don't actually have to solve the equation. We just have to find the step that would help us solve the equation. A, for this first equation, we can get the x by itself by dividing both sides by 5, or multiplying each side by 1/5. And 1/5 of 5x is 1x, or x. B, x over 5 equals 8. That's the same as x divided by 5 equals 8. So we have to undo that division. So we would need to multiply both sides by 5. Because we want to get the x by itself, and x divided by 5 times 5 gets back to 1x, or x. C, 3 equals -x over 5, or -x divided by 5. We need to multiply both sides by 5, but not just by 5, but by -5, because a negative times a negative equals a positive, and we'd like that x to become a positive. So we have to multiply both sides by -5. Doing that would make the x a positive 1x or a positive x. D. 7 equals negative 5x. In this case, x is being multiplied by negative 5. To undo that operation, we'd have to divide by a negative 5. And dividing by a negative 5 is the same as multiplying by a negative 1/5. So we have to multiply both sides by a negative 1/5 to get the x by itself and make it a positive 1x or positive x. Problem number 4. A. Write an equation where a number is added to a variable and a solution is negative 8. Let's start with a variable and add a number to it. Here we have x plus 5, and the solution needs to be negative 8. That means that the value for x is negative 8. So if the value for x was negative 8, then negative 8 plus 5 would be negative 3. So the equation where a number is added to a variable and the solution is negative 8 could be x plus 5 equals negative 3. Let's test it out just for the heck of it. To get the x by itself, we have to subtract 5 from both sides. Now we have the x by itself, and it reads x equals negative 3 and negative 5. That's a total of 8 negatives. So x equals negative 8. Remember to write this equation as your answer. X plus 5 equals negative 3. B. Write an equation where a number is multiplied by a variable and a solution is negative 4/5. This time they want to multiply a number by a variable, and the solution needs to be negative 4 over 5. So we can use 5/4 x equals negative 1. That's because when we multiply 5/4 times its negative reciprocal, the answer is going to be negative 1. So you could write this equation as your answer. 5/4 x equals negative 1. Problem number 5 from 7th grade, Unit 5, Lesson 8. The markings on the number line are evenly spaced. Label the other markings on the number line. Let's use the existing markings to help us out. Start at 0, and it looks like we have to move 2 dashes to the left to get to negative 1. That means that every 2 dashes is a whole number when you start from 0. 2 dashes to the right of 0 would be positive 1, 2 dashes to the left of 0 would be negative 1, and 4 dashes to the left of 0 would be negative 2. The dashes between the whole numbers are evenly spaced, so those dashes would represent half units. For example, 1 dash to the right of 0 would be 0.5, and 1 dash to the left of 0 would be negative 0.5. Problem number 6 from 7th grade, Unit 5, Lesson 12. In 2012, James Cameron descended to the bottom of Challenger Deep in the Marianas Trench, the deepest point in the ocean. The vessel he rode in was called Deep Sea Challenger. Challenger Deep is 35,814 feet deep at its lowest point. A. Deep Sea Challenger's descent was a change in depth of negative 4 feet per second. We can use the equation y equals negative 4x to model this relationship, where y is the depth and x is the time in seconds that have passed. How many seconds does this model suggest it would take for Deep Sea Challenger to reach the bottom? Let's use the information they gave us. Negative 35,814 divided by negative 4. Negative 4 represents descending feet per second, and negative 35,814 represents the total number of feet they need to descend. The model suggests that 8,953.5 seconds will pass while Deep Sea Challenger reaches the bottom. B. To end the mission, Deep Sea Challenger made a 1-hour ascent to the surface. How many seconds is this? The ascent was 1 hour. That means that it was going back up to the surface and it took 1 hour. Well, we know that there's 60 minutes in 1 hour and 60 seconds in each minute. Since the ascent took an hour, we can multiply 60 seconds times 60 minutes, and that tells us that there were 3,600 seconds in the ascent. C. The ascent can be modeled by a different proportional relationship, y equals k times x. What is the value of k in this case? Y equals k times x. K is the constant, the distance that it traveled up during the ascent divided by the number of seconds that it took to make the ascent, which was 3,600 seconds. You can see here I wrote y equals k times x, but I substituted the k with 35,814 over 3,600. Seventh grade Open Up Resources Illustrative Mathematics, Unit 5, Lesson 16, Representing Contexts with Equations. Problem number 1. Match each situation to one of the equations. A whale is diving at a rate of 2 meters per second. How long will it take for the whale to get from the surface of the ocean to an elevation of -12 meters at that rate? We're looking for an equation that's going -2 meters for an unknown time to take them -12 meters. Situation A matches perfectly with equation 3. B. A swimmer dove below the surface of the ocean. After 2 minutes, she was 12 meters below the surface. At what rate was she diving? We're looking for an equation that has the diver diving for 2 minutes at an unknown rate to get -12 meters. Situation B is a perfect match with equation 4. C. The temperature was -12 degrees Celsius and rose 2 degrees Celsius. What was the change in temperature? We're looking for an equation that represents a temperature being -12 degrees and then increasing an unknown amount to become 2 degrees Celsius. Situation C is a perfect match with equation 1. D. The temperature was 2 degrees Celsius and fell to -12 degrees Celsius. What was the change in temperature? We're looking for an equation that represents a temperature starting at 2 degrees, then falling an unknown amount and becoming -12 degrees. Remember, x could be a negative number. Even though you're adding x, you could be adding a negative. So equation number 2 is a perfect match for situation D. Problem number 2. Starting at noon, the temperature drops steadily at a rate of 0.8 degrees Celsius every hour. For each of these situations, write and solve an equation and describe what your variable represents. A. How many hours did it take for the temperature to decrease by 4.4 degrees Celsius? We can write the equation like this. 0.8 degrees times an unknown amount of hours equals 4.4. Since the temperature was dropping 0.8 degrees, we can put a negative sign, and the temperature decreased by 4.4 degrees, so we can put a negative sign there too. To get the h alone, we need to divide both sides by -0.8. Since a negative divided by a negative equals a positive, both sides of the equal sign will be positive. That means on the left side we have 1h, or h, and on the right side we have 5.5. That means it took 5.5 hours for the temperature to decrease by 4.4 degrees. B. If the temperature after the 4.4 degree drop was -2.5 degrees Celsius, what was the temperature at noon? We can write an equation to represent this. Let's write T for the time at noon minus 4.4 degrees Celsius equals -2.5 degrees Celsius. To get the t by itself, we need to add 4.4 to both sides. That gives us the t all by itself on the left-hand side and 1.9 on the right-hand side. At noon, the temperature must have been 1.9 degrees Celsius. Problem number 3 from 7th grade, Unit 4, Lesson 3. Kieran mixes 3/4 cups of raisins, 1 cup peanuts, and half a cup of chocolate chips to make trail mix. How much of each ingredient would he need to make 10 cups of trail mix? Explain your reasoning. Let's use the information they gave us to see how many cups of trail mix this recipe makes. 3/4 of a cup plus 1 cup plus a half a cup. A half a cup is the same as 1/4 plus 1/4, and if I add one of those fourths to the 3/4, that would total 4/4, or 1 cup. Now we can add 1 cup plus 1 cup plus the 1/4 cup that was left over, and we have a total of 2 1/4 cups. This tells me that Kieran's recipe makes 2 1/4 cups of trail mix. Now if he were to make 10 cups of trail mix, I need to see how many times larger 10 cups is compared to 2 1/4 cups. 10 divided by 2 1/4. I can write 2 1/4 as a decimal, 2.25. 10 divided by 2.25. That'll tell me how many times larger 10 cups of trail mix is compared to the 2 1/4 cups in Kieran's recipe. It turns out 10 cups of trail mix is 4.4 repeating times larger than 2 1/4 cups. This means that each ingredient will be multiplied by 4.4 repeating to figure out how much of each ingredient Kieran will need to make a total of 10 cups of trail mix. Let's take a look at the original ingredients and their amounts. 3/4 of a cup of raisins, 1 cup of peanuts, and a half a cup of chocolate chips. Next, let's multiply each of those by 4.4 repeating. 3/4 times 4.4 repeating equals 3.3 repeating cups of raisins. 1 times 4.4 repeating equals 4.4 cups of peanuts. And 1/2 times 4.4 repeating equals 2.2 repeating cups of chocolate chips. Problem number 4 from 7th grade, Unit 5, Lesson 6. Find the value of each expression. A. 12 plus -10. That's the same as 12 minus 10. And 12 minus 10 is 2. B. -5 minus 6. Imagine a number line starting at 0. Move 5 to the left and move 6 more to the left. You've moved a total of 11 to the left. So -5 minus 6 is -11. C. -42 plus 17. That's kind of like 17 minus 42. There's more negatives than there are positives, so the answer is going to be a negative, and the difference is 25. So -42 plus 17 equals -25. D. 35 minus -8. I like to look at this as 35 and the opposite of -8. And the opposite of -8 is +8. So this has the value of 35 plus 8. And 35 plus 8 is 43. E. -4.5 plus 3. Again, there's more negatives, so I know the answer is going to be a negative. And the difference between 4.5 and 3 is 1.5. So -4.5 plus 3 equals -1.5. Problem number 5 from 7th grade, Unit 5, Lesson 8. The markings on the number line are evenly spaced. Label the other markings on the number line. I notice that there's 2 even spaces between 0 and -30. So if I divide -30 by 2, I get -15. So each space is worth 15. So for example, if -15 is to the left of 0, then +15 is to the right of 0. Moving one more space to the right of 15, I have to add another 15. So 15 plus 15 is 30. Let's count by -15, starting at 0 and moving left. -15, -30, -45, -60, -75. Problem number 6. Kieran drinks 6.4 ounces of milk each morning. How many days does it take him to finish a 32-ounce container of milk? A. Write and solve an equation for the situation. We can write an equation that represents 6.4 ounces times an unknown number of days equals 32 ounces. And that would be 6.4D equals 32. Next, we need to solve. So let's solve for D. We can do that by dividing both sides by 6.4. On the left side, we have D by itself, and on the right side, we have 32 divided by 6.4, which equals 5. It would take Kieran 5 days, drinking 6.4 ounces of milk each morning, to finish 32 ounces. B. What does the variable represent? The variable D represents the number of days it takes Kieran to finish the container of milk. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time.